In this video, we're going to go over how to add vectors end-to-end, component-wise, and by the parallelogram rule. So let's say that we have y plus z, where y is 8, 1, and z is 1, 6. So you're going to add 8 plus 1 and 1 plus 6, 9 and 7. So now let's say that you have f plus g. This is going to be 2, 8 plus 3, 1. You would get 2 plus 3, 8 plus 1, and 5, 9. Let's say you had p plus q, where we had 5, 1, and 2, 3. So that's 5 plus 2, 1 plus 3, 7, 4. Let's say that we had a vector j that's equal to 2, negative 6. K is 2, negative 2, 4. And we want to find j plus k using component addition. So this is 2 plus negative 2. You could also write this as the linear form or as a column vector. Matrix. What about if we had m is 3, 4, n is negative 1, 2. So let's say that we had two vectors like this. If we had a 3, 4, that would be 3. And we would have negative 1, 2. If we wanted to find the sum of m plus n, our result, m plus n, would be somewhere in between. So that's going to be when we're at 2, 6. It can also be represented by using the parallelogram, which would be this. Since the opposite sides here are going to be congruent, because we have this figure. We could also write this as 6i plus 2j. Or no, we couldn't. We could write this as 2i plus 6j. We could also write this 2, 6. Actually, we'll just leave it at that. So for our next question, let's say we have h plus I sum. This would be a negative 9, 2, and a 4, negative 7. We're going to have negative 9 plus 4, 2 plus negative 7, negative 5, negative 5. what if we want to get d plus e? We would add like we'd keep doing. What if we had m plus n? We would get -4, 5. Now, let's say we had these vectors. You're going to add your x components. And y. So we get this. Let's say we have x plus y plus z. So for our x components, we have 5/4 plus -3 plus 1.25. What you can do is write 5/4 as, or 1.25 as 5/4. So we have 10/4 minus 3. Which will give you 5/2 minus 6/2, which will be -1/2. And here we have 1.5 plus -2/3 plus 1/6. We have 1.5 is 3/2. And 3/2 is 9/6. -2/3 is -4/6, and we can keep that. So we can do just in the top, 6/6 is 1. Now let's find our resultant vector for this. So this will give us 0, 1, 2.